Good morning. Now let's take a look on some acceleration problems taken from OpenStax College Physics. Problem 17. Dr. John Paul Stapp was U.S. Air Force officer who studied the effects of extreme deceleration on the human body. So again, deceleration means slowing down, extreme slowing down from very fast speed to stopping. That involves a lot of force. So on December 10, 1954, Stapp rode a rocket sled, accelerating from rest to a top speed of 282 meters per second in 5 seconds, and was brought jarringly back to rest in only 1.40 seconds. Now we are asked here to calculate his acceleration and his deceleration, or part B, okay, and express it in multiples of g. Now, let's visualize this problem. Okay, a rocket sled, meaning it's a sled with rocket propulsion. So, shall we say it's moving on a very straight path, and the sled could be thought of starting from this position here. Okay, the start. So there's a sled. Okay, and the person is here. The doctor stop is here, and then this sled at this point, the v is 0, meaning this sled is not yet moving, and it's accelerating, meaning it's speeding up. It's speeding up, and it's now here. Let me just draw the sled again. I hope I can still draw it. Okay, the sled is here, but at this point now, the sled is now at v equal to 282 meter per second. Okay, we don't know how far will that be, but during that time, the time it took for the sled to to accelerate. This is not distance, okay? So this is just time. The time it took for the sled to accelerate from 0 to 282 is only 5 seconds. So that's quite fast, okay? 5 seconds. Now, however, this sled is being brought to stop again. So meaning brought to stop for only a period of 1.40 seconds. So meaning that sled is now here. Okay, hope I can still draw it. And now the V now is back to 0. And this time here is just as short as that time is just 1.40 seconds. Okay, and the time where the sled is brought back to rest. Now, let's try to work out the acceleration, meaning solve how fast is the sled accelerating during this time. Again, to solve for acceleration, it's just very simple, right? The formula is just straightforward. A, during this time interval, is just change in velocity with respect to the time. So the velocity here is changing. Final velocity is 282 minus 0, so 282 meters per second divided by time of 5 seconds. So here it's very clear that the average velocity, average acceleration during that first time interval where the sled is accelerating is simple as 282 divided by 5, or that's what? 56.4 meters per second squared. Okay? And how about the second part? By the way, we are asked to express this in terms of multiples of g. So what do you mean by that? So here, take a look. A is equal to 56.4 meters per second squared, but most of the time we want to express, meaning compared to acceleration due to gravity, g, meaning how many times is it bigger? So we can just work here, 1g, okay? 1g is equal to 9.80 meters per second squared, or simply we can say that it's accelerating at what? Divided by 9.8, it will be what? 5.76. So 5.76 g, meaning, oh, it's accelerating 5.76 times that of the acceleration due to gravity. Note that g here is not what? G is not gravity, but G is not grams, but G is the 9.80 meters per second squared acceleration due to gravity. Now, how about in this case? How about this one? The one where we have now the deceleration part. By the way, deceleration is essentially just acceleration. The same thing, delta V over delta t. Okay, delta v, final velocity is 0. Initial velocity is 282 during the second phase. Okay, meters per second divided by the time here is 1.40. And take note that we are getting there a what? 282 divided by 1.40. Oh, no, no. Um, uh-oh. Again, 282 divided by 1.40. Okay, that will be negative 201.43. Okay, negative 201.43 meter per second squared. And again, expressing that in terms of g, let me write that down here. Negative 2, again, 201.43 meter per second squared multiplied by 1g is just 9.80 meters per second squared, or that's equal to, so meaning I divide that with 9.80. Okay, and it's giving me a 20.56 or 20.55. 20.55 G. So take a look. By the way, the negative here corresponds to what? The negative simply corresponds to that this is slowing down. Okay? The what? A negative acceleration. For this case, it's deceleration, I mean. A negative means it's decelerating, so slowing down. So it's quite a big what? Big number, right? 20.55 times that of the G. And later you will realize that this acceleration, there's a corresponding force to it. Meaning the bigger your acceleration magnitude, that means the bigger the force you are experiencing. And of course that will have an impact to the body, right? That's why it must be taken care of, that you don't accelerate too fast, because that will correspond to bigger force that you are experiencing and your body may respond to it. Thank you.